All right, I'm going to work through a few of these optimization questions very quickly. So let's just get started. The following triangle has a height of 2x and a base of x plus 5. So the height is 2x, base is x plus 5. I'm going to start off by just creating an area equation because, well, that's actually the first question. Find the function of the area in terms of x. Okay, so an area equation here would be simply a equals 2x times x plus 5. Now that's base times height. Base times height. So remember, let me write this above. Area equals base times height, or length times width, however you want to write it. But the difference is between a triangle and a rectangle is you have to divide by 2. So area equals base times height divided by 2. And in this case, base times height divided by 2. All right, so I'm going to continue refining this area equation so it's a little more manageable. So I'm going to begin by multiplying 2x and distributing into this whole thing. So I'm going to write it over here too. A equals, so I've got 2x squared plus 10x divided by 2, like that, 2x squared. So that's coming from distributing. 2x squared, 10x, still divided by 2. And then I'm going to simplify by dividing by 2 each of the terms in the numerator. So I've got x squared plus 5x. That equals the area. Okay, so there's my area equation. Now it says if the area of the triangle is 36 centimeters, find the height and base. So again, guys, I'm just trying to get you to think a little bit. You should not plug 36 into the x. X is not representing the area. The a is representing the area. So if I'm going to solve this and I'm going to find the height and the base, I need to solve for x. So I'm going to have x squared plus 5x equals 36. And as you can see, my 36 is the actual area. Now, I'm going to go ahead and do this on a separate sheet of paper. Just because there's not really much space on here, so I guess in class you guys are going to need to work on a separate sheet of paper too. So separate sheet of paper, here it goes. If I want to solve this by hand, I could factor it. X squared plus 5x minus 36 equals 0. I could solve that by factoring it. I could use the quadratic formula. Here it is factoring it. Two numbers that multiply to be negative 36 and add to be 5. X plus 9, positive 9 times negative 4. That equals negative 36. Positive 9 minus 4 is 5. Okay, so all of this, actually, if I multiplied it out, I'd get right back to where I was. So it's the same thing, except factored. And factoring helps us solve it. So if x equals negative 9, that would be a solution. Or if x equals positive 4, that would be a solution. Now the thing is, only one of these actually is true. So for example, if I take negative 9 and I plug it in for my x, then I'm saying that I have a height of 2 times negative 9, or I have a height of negative 18. That doesn't actually make sense. That's not even a non-existent height. It's almost like an anti-height. So it's not negative 9. That makes no sense in the context of this, this problem. So x has to be 4. And if x is 4, the question is, find the area of the triangle, of the triangle. Oh, sorry. If the area of the triangle is 36 centimeters, find the height and the base. So if x is 4, the height is 2 times x, so 2 times 4, which is 8. If the base, all right, if the height, or if x is 4, then the base is 4 plus 5, which is 9. Okay, and that should do it. Going on to the next question. Let's see. It says the length of a rectangle. By the way, on the last question as well, if you wanted to do that by the calculator, you could type it in. I would just type it in, honestly. You could set it equal to 0, or you could type it in just like this. This x squared plus 5x equals 36. You could type it in just like that. And actually, here, this is what you do. I'll just do it. Why not? Okay, here we go. I would type in x squared plus 5x. And the question is, when does x squared plus 5x, when does this parabola right here equal 36? So I'm going to type in another line, at 36. And I'm going to look at the intersections. And the intersections, if I did do all of my factoring right, should be at -9 and +4. I can't see 36 high. I can only see 6.43 high. So I'm going to go ahead and change my scale up a little bit. Or maybe I'll just, yeah, I'll change my scale. So 4, 1, all right. I want to see as high as 36, so let's go to 40. And sure enough, your intersections are at 4 and at -9. And to find those, you just menu, analyze graph, 4, intersection. And it'll tell you, click, drag over here. This one's at 4 and 36, and the other one would be at -9, 36. All right, moving on to the next question. It says, the length of a rectangle is 7 feet less than twice the width. Okay, so the length of the rectangle is 7 feet less than. Length is 7 less than twice the width. Okay, and it says write the function of the area in terms of the width. All right, well, remember, area is length times width. Okay, so with that being said, then I know that area is going to be, here's length. Length is 2w minus 7, so it's going to be 2w minus 7. So instead of writing length here, I'm writing length like this. Length times width. So multiply it all out like this. I have area equals 2 width squared minus 7 width. So there's my area. Look, right here. Area in terms of width. So there's my area in terms of width. They're both width, okay? All right, so it says if the area is 15 feet squared, find the dimensions. Okay, so if area is 15, so to solve this, you just need to have 15 equals 2w squared minus 7w. So I mentioned on the last one, you could factor some of these. Not everything's factorable, so remember that. But you could factor some things. You could also use the quadratic formula by setting it equal to 0. So this one, I'll actually go ahead and just use the calculator. So I'm going to take this right here, clear it out. Again, this is coming from the 15 is saying that the area is, the whole equation is coming from area equals 2 width squared minus 7 width. But when the area is 15 feet squared, I'm going to find the dimensions in just a second. So tab, you can do, make a line at 15. There's one. The other one is going to be at 2x squared minus 7x. There's the other one, the intersections, menu, analyze graph, intersection. And really you're concerned with a positive intersection. So it says 5, 15. I'm not even concerned with a negative, so I'm not even going to do it. So at 5, now that 5, so the intersection, let me write it down real quick. The intersection was at 5, 15. And what that's saying is that when the width is 5, the area is 15. Okay? So the intersection's at 5, 15. So when the width is 5, the area is 15 feet squared. Okay. So what's the length? How do I find that? Well, the length, right here, if you look straight above, says the length is 2 widths minus 7. So width is 5. Okay. So it's 2 times 5, which is 10, minus 7. So the length is 10 minus 7. So the length is 3. And there's the solution. Okay, next one. Find the perimeter. Well, that's easy. If you have the length and the width, then say you have a width here, a width here, a length here, a length here. So you have 5 plus 3 plus 3 for a total of 16. And keep in mind, we are working in feet. We're talking about feet squared would be the area. So this is 5 feet. Length is 3 feet. Okay, moving on, guys. Let's do one question from the back side. Some of these people have a pretty difficult time with. I'm going to do this one. And let's see. I hope I haven't been recording for too long, but I'm going to get it done real quick. So it says, Ken Graham has 1,200 meters of fencing meters of fence to put around 2 rectangular yards. If the yards are to be separated by part of the fence, what would the length and width? What would be the length and the width for the maximum area? Okay, so there's multiple ways you can do this. You can do this entire side as one length or one width, and that entire side as one length and one width, or you can do length, 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 and have 4 of them. You'll get the same answer both ways. So I'm going to go ahead and say that the entire side, the whole thing, is length. So just to communicate that again one more time, you can say length, 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 or you can just say this is one length and that's the other big length. And then you have width, width, width. Remember, you have a big length on the other side. Okay, so what we have actually is, for all the fencing, a length, and 3 widths. So we have 2 lengths plus 3 widths equals 1,200 meters of fencing. The other equation I'm going to write over here is the area, because we're trying to maximize area. Area is length times width. I'm going to use this to isolate one of the variables and substitute it into this equation so I can actually solve and maximize the area equation. So I'm going to go ahead and try to isolate L. It doesn't matter if you isolate L or W. Just so you know, I'm going to isolate L though. All right, so divide by 2, and no matter which case you do, if you isolate L or W in this case, you're going to get fractions. So you're going to have to learn to deal with fractions. All right, so length is -3 over 2W plus 600. Now I isolated one of the variables so I can plug it into this equation. So here's the area equation that I'm going to be using. A equals length. Now instead of writing length, I'm going to write what length is. Length is -3 over 2W plus 600. So length, -3 over 2W plus 600. Length times width, like that. All right, and then from here, I'm going to go ahead and start distributing. So let's see if I can zoom in on here. All right, from here, I'm going to actually start distributing in so I can have a more manageable area equation. That's not necessary, but I like to usually kind of combine like terms and distribute and make it as simple as I possibly can to deal with. -3 over 2W squared plus 600W. And that's my area equation that I'm going to be using. Now the whole deal is, all I need to do is maximize this. So I can actually use -b over 2a to find my vertex. -b over 2a, that will find my vertex. So -b is -600 over 2 times a. All right, 2 times -3 over 2, that should be -3. You guys can type it into your calculator and check me, but I'm pretty sure that is correct. So it equals 200. All right, so what equals 200? Whatever's in this area equation. So the width is 200. So when the width is 200, I maximize my area. So what is my area going to be? Take the 200, plug it back into your area equation. So I've got, now I'm going to need a calculator on this part. Let me go ahead and close out of this. Let's see. Oh man, sorry, I just went off screen with that. Okay, so this last part, I'm just taking the 200 that I got from using -b over 2a from my area equation, taking that 200, and let me get rid of this too. Taking the 200, and I'm plugging it back into this equation to find out what the maximum area is. So when the width is 200, I have a maximum area of -3 over 2 times 200 squared. All right, and then plus 600 times, I'll just type it out like that, times 200. Okay, so 60,000. So what was the question actually asking? It says, what would the length and width be for the maximum area? So the maximum area is 60,000 when the width is 200. When the width equals 200. And to find out what the length needs to be, I could take that 200 and I could plug it into really any one of these equations. I'm going to go ahead and plug it into here for this width. Okay, so length is going to be -3 over 2 times, times 200. And then I'm going to have plus 600. So 300. So then the length after I type in the 200 for width here, length is going to be 300. Okay, guys. So hopefully, zooming out now, hopefully that helped you. And if not, you can always come see me before school. I'm always here early. So I'll see you guys in class.